Okay, in this video we'll do rational inequality question number 5. And this is very typical question on calculus class, okay? And let's see. Oh, on the other side I have a number 0. That means you're making this equation as 0 and you don't need to look at the denominator, okay? Whatever you get 0 from the numerator is 0 and then quotient will be 0, right? So what are the numbers you get from the numerator? If your numerator is 0, you get x value as -3 and -5. If we are looking at excluded values, you are looking at denominator, right? So look at the denominator. Which number makes denominator 0? So you solve it and x will be -2. So this should not be equal to, right? So those are my boundary numbers for the number line. So no distributive property. We love this, right? So we have a 0 on one side and I have boundary numbers. Okay, all are negative numbers. So let's put them in order. Which one is on the right side? -2. Losing $3 would be better than losing $5, right? Yep, so let's list them in order. Smallest on the left, highest on the right. And now let's test each interval. Because I have 3 points, how many intervals do I need to test? 4 intervals, right? So I have 4 places to test. So let's pick a number between those, okay? Give me a number less than -5. That's right. Give me a number between -3 and -5. That's right. And then give me a number between -2 and -3. -2.5. Good number. Give me a higher number than -2. Good choice. 0. Okay, so let's test it, okay? So if I test x as 0, and I'm going to have this inequality, right? So let me write this over here. And then I'm going to use the plus minus signs and then check, okay? Instead of calculating. Hello? Okay, so I had a phone call and let's back to the problem and then let's see how we check the inequality, okay? If I choose number 0 for this and let's see, 0 plus 3, 3, 0 plus 5, 5, and denominator 0 plus 2 to all positive numbers, right? Is it going to be positive number? Yes, greater than or equal to 0 means positive number. So yes, this is true. So I'm going to shade that region, okay? Yes, this works. Next one, I'm going to plug -2.5, okay. So if I plug -2.5 in this inequality, first one, -2.5 plus 3, that is positive, right? Okay. Next one, -2.5 plus 5, that is also positive. Denominator, you plug -2.5 plus 2, that is going to be negative, right? Yeah. So what will be the sign for this? Negative. So is that greater than or equal to 0? No, that is negative. So no, so that's false. Okay, so I don't take this region between -2 and -3. That's not the solution set. I'm checking only positive, negative signs because the inequality has 0 on the other side. It means positive or negative, okay? Number 4, let's plug number -4. So by plugging -4, the first factor will be negative. Second one, positive. The denominator gets negative. 2 negatives makes positive, so this will be true. So I will take this region. Yes?
No, I felt bad, sorry. But what if you do it and it equals 0, what would you put as a sign?
Equal sign, 0?
No, like
If you plug 0 here, that's plus, plus, plus. All 3 plus makes plus, so that is true.
Yes, like let's say for the x plus 3, you had like -3 as your x, and it was 0. What would you put as a sign without actually plugging it in?
I don't use negative 3 as a number. Negative 3 will make everything 0, and this will be still true statement because inequality says equal to 0 or greater than, okay? So that will be still true statement. Okay, let's plug negative 6 in the inequality and let's check signs. First factor will be negative, second one will be negative, and denominator will be also negative. 3 negative signs make negative. Is it greater than or equal to 0? No, so I'm not taking this region as solution set. Now let's make a decision on the open closed circle, okay? Excluded value is always excluding open circle, okay? Open. There is a hole here. And the other two is coming from this problem, okay? So since that is included, so I need to include these 2 points, negative 3 and negative 5. Those are including. And I need to shade the region here. And I need to shade this region because I tested with those numbers in that given interval, it worked. That means the inequality is true, okay? So we are taking that part. Am I done? No, not yet. What's missing here? Answer is missing, right? So this is how we graph this inequality solutions on the number line. Let's write the answer. So negative 5 and negative 3 both are included. Union with, and I have another section, so negative 2 to infinity. In the future, in pre-calculus class, we use notations using interval a lot, so let's be familiar with this type of notations, okay? If you want to write your notation using inequality, you can say x is between negative 5 and negative 3, both ends inclusive. Or x is greater than or not equal to, x is greater than negative 2. And you can put curly braces and then put x as a variable. That is the element in condition of this, and that's how we write the set field notation for the solution set.